So one example on the ratio test, and we'll do an example on the root test as well, okay? So the series, let me see, n equals 1 to infinity. Let's do -1 power n times 3 power n over n factorial. Okay, so I want to know whether this series converges or diverges.
How do you treat it?
Okay, let's go. Let me show you. So anytime you see factorials, chances are you're going to have to use the ratio test. Okay, and I'll show you why. So you know what factorial is? You all remember what that is? I showed you before. Okay, so n factorial is 1 times 2 times 3 times 4 all the way up until n. Okay, so my ratio test is limit as n approaches infinity of, so an plus 1, basically this with an n plus 1 everywhere. So an, so -1 power n plus 1, 3 power n plus 1 over n plus 1 factorial. Okay, that's an plus 1 over an, which is -1 power n, 3 power n over n factorial. Okay, and all this, of course, in absolute value. I have to evaluate this limit as n approaches infinity. If this limit gives me a value that is less than 1, the series converges. If it's greater than 1, it diverges. If it's equal to 1, I have to do another test. Okay, that's the idea. So let's do the algebra here. Limit n approaches infinity, and I'm going to put everything on one fraction. Okay, so -1 power n plus 1, so it's -1 power n times -1 power 1, times 3 power n plus 1, which is 3 power n times 3, over n plus 1 factorial. Okay, now n plus 1 factorial, let's leave this term for now. Okay, let's put the other terms here. Okay, so there's an n plus 1 factorial that needs to be put on the bottom. We're going to put it in a minute. Let's put what's on the bottom, -1 power n, 3 power n, and then the n factorial goes on top. Okay, so the only thing missing here is n plus 1 factorial. Right? You all good with this? You following me? Okay. But n plus 1 factorial, what is that? Well, this is 1 times 2 times 3 times 4, all the way until n times the last term is n plus 1. That's what it is. Okay. And 1 until n, well, this is n factorial. So n plus 1 factorial is actually n factorial times n plus 1. So that's what I'm going to write here. N factorial times n plus 1. Who doesn't understand what I just did? Don't forget the, of course, absolute value.
I don't get it, sir. Can you explain again, please?
Sorry, you don't understand? You understand what I just did here?
Yeah.
Okay, so what's n plus 1 factor? This one, right? What's in orange here? Or before? What don't you understand?
Orange.
Okay, so imagine I have, okay, for example, let me give you an example here. Let's say I have 6 factorial. Okay, so 6 factorial is what? Is 1 times 2 times 3 times 4 times 5 times 6. Is that okay?
Yeah.
Okay, but 1 times 2 times 3 times 4 times 5, what is that? That's 5 factorial, right?
Yeah.
That's what it is. So 6 factorial is 5 factorial times 6. Same here. N plus 1 factorial is n factorial times n plus 1.
Yeah, I get it now.
Okay, good. Okay, anybody else need more explanation for this? Okay. So at this point, it's time to clean things up here. So negative 1 power n, negative 1 power n is out, 3 power n, 3 power n is out, and okay, this part is always very satisfying. And what do I have? Limit as n approaches infinity. So the absolute value of negative 3. So basically, it's just 3. Okay, well, I'll do an extra step. So 3 over the absolute value of n plus 1, which is just n plus 1, because, of course, n is positive. And this is 0, right? 3 over infinity is 0, which is less than 1. And so my series converges. Okay, so my series n1 to infinity, negative 1 power n times 3 power n over n factorial converges by the, and you have to write, ratio test.
Sir, I think Faye's in the waiting room.
Oh, let me just let them in. So here's a root test question. So this we haven't done yet. So let's say 1 minus 2 over n to the power of n squared. Okay, and here's a series. I don't know if it converges or diverges, but what I do see is that the whole term is to the power of n or n squared or n something. When that's the case, the root test is very appropriate, okay? So let's try. So let me remind you what the root test is. Okay, the root test is that if limit n approaches infinity, okay, of the nth root of the absolute value of a n, okay, so if that is less than 1, if that is equal to 1, or if that is greater than 1, okay, so if it's less than 1, the series converges, bigger than 1, the series diverges, and equal to 1, the test fails. Okay, that's the root test. So what I'm going to do now is I'm going to find the limit of the nth roots of this whole thing. Okay, in absolute value, but since n is very big, this is very small, well, that's big, that's definitely positive. Okay, definitely less than 1. So I don't need the absolute value in this case. Let's do this. So how do you do this power n2 nth root? How do you do this?
You convert the fraction, the exponents
into a fraction. So the exponent is the power. The nth root means power 1 over n. Okay. So okay, I'll just do it. So 1 minus 2 over n power n2. All this to the power of 1 over n. Okay, and therefore now we could multiply the exponents here, so it's just n. So it becomes limit as n approaches infinity of 1 minus 2 over n to the power of n. Okay, so I have to evaluate this limit and determine whether it's greater, equal, or bigger than 1. Sorry, it's less than, equal, or bigger than 1. Yeah. Okay, so how do I do this? You remember how to do this limit?
Using L'Hopital's rule?
Yeah. I can't use it right away. I have to do some manipulations, right? You remember
Do we
this?
take ln of both sides?
Very good. Okay, so let's call this limit L as n approaches infinity of, so 1 minus 2 over n power n. And then if you remember, we took ln on each side. Oh, you can see? You can see, right? Let me just move it a bit. Still can't see, so we'll move it. Okay, I could see. Okay, and then of course I have to put ln on each side, so I have to put ln on the left and on the right. That allows me to bring down the n. So limit as n approaches infinity of n times ln of 1 minus 2 over n. And now if I plug in infinity here, I have infinity times ln of 1, which is 0. So I have infinity times 0. Okay, so if I wanted to find the undetermined form here I had 1 power infinity. Now I changed it into infinity times 0, right? Infinity times 0. And the last thing I'm going to do now is I will send the n on the bottom. And so I get ln of 1 minus 2 over n over, and if I send n on the bottom, it becomes 1 over n. And now I get 0 over 0, which allows me to use L'Hopital's rule now. Okay, so we did problems like this before. Okay, let's continue here. So it's equal, and now I'm going to apply L'Hopital's rule. I'm going to put a little h here. Limit as n approaches infinity. And the derivative of the top, so derivative of ln is 1 over this, times, of course, chain rule, so I derive the inside, which if you derive 1 minus 2 over n gives you 2 over n squared. And the derivative of the bottom, the derivative of 1 over n is negative 1 over n squared, that you should remember from calculus 1. Okay, and what happens now? n2 and n2, they disappear. When n goes to infinity, 2 over n, this goes to 0. And so what am I left with? I'm left with 1 times 2 over minus 1. So I just have negative 2. Okay, so ln of L is equal to negative 2, which means that L, so let me just write ln L equals to negative 2, which means that the limit is e power minus 2. Okay, which is like 1 over e squared, which is of course less than 1. Okay, so the limit of the term, of the nth root of the term, gives me 1 over e squared, which is less than 1. Therefore, my series converges because we're following this case here, on the less than 1 case. So the series n1 to infinity 1 minus 2 over n power n squared converges. And this is thanks to the root test.